Hey everybody, welcome to Studio Review. It's Kyle, and today we're going to be reviewing MovieSQLs. What we're trying to accomplish here is to write the SQL queries to retrieve or modify information from our database tables. We're also going to be exploring the parallels between Java objects and tables to really see the similarities and differences between Java and our database table information. So let's start by opening up MySQL Workbench. We're going to see the MySQL connections here that we've created previously. Type in our password that we have for encryption. And we're in. So the first thing that we were asked to do in this studio is to create a new schema called MovieBuff. To do this, we'll go back to our MySQL workbench, drag our cursor to the top left, click that cylinder with the plus sign on it, and then type in MovieBuff into our new schema name, and then press apply. We'll then see our entire query here that will create our schema, press apply again. Then we'll see it's been successfully created, click close, and then we should see MovieBuff on the left side underneath schemas. In this studio, we are movie buffs, so we need to create two very important tables, one for movies and then one for directors. I know it might be tempting to just start implementing these tables right off the bat, but let's first take a step back. Let's design first, and then we'll implement. This will give us a clear picture of what we need before we go back to MySQL Workbench and implement these into our database. So let's get out a piece of virtual scratch paper, write down a table with column name in the first column, example data, and then data type. And then let's fill this in with what data is going to go into our movies table. The first column might be a little obvious. We're going to start with the title of the movie. In this example, I'm going to be using Zombieland since that's my favorite movie. But what might not be obvious is the data type we're going to choose to represent this entry. Zombieland, though, is not a number. It's not a date. It's not a time. But it is a string. But string is a Java or JavaScript concept. So in MySQL, we actually call this a varchar, or a variable character, that is set to a specific limited amount of characters. In this case, 120. Therefore, our movie title can't be more than 120 characters. The next column we'll do is years released, which for this example is 2009 when Zombieland was released. So 2009 is technically a date. It's a year somewhere on the calendar. But with this date, we don't actually have a month or a day assigned with it. It's just the year. Therefore, it's a numeric value. So for this column, we can actually use integer as our data type. The third column is going to be the director's name of who directed the movie. In this case, it's Ruben Fleischer, which is a name, as we know is also a string, but in MySQL, we call that a varchar. In this case, this varchar is going to be of maximum length 80. The final column is going to be the movie ID, which is going to be extremely important because it's going to be the unique identifier for each row in our movies table. We need a unique identifier because two movies can have the same title. Therefore, we cannot rely on that. We need an ID that stays unique for each row in our table. These unique identifiers can be strings or numbers, but in this case, we're going to be using numbers. Therefore, our data type is an integer. So great, we almost have all the information we need to build this movies table. We have all of our column names and all of its associated data types. But we're missing one thing, and that is the primary key. The primary key is typically the column in which the unique identifier, or an ID, lives. In this case, movie ID was our unique identifier. Therefore, our primary key is going to be movie ID. But why do we use a primary key? It's the same reason that we use house addresses. Just how you might want to find your best friend's house, primary keys allow us to find information inside of our database. If another table wants to try to find a specific movie in our movie table, we need to have an address or an ID for them to find it. Therefore, a primary key offers that, so we can share information between tables, which will become very useful here in this studio. All right, so let's take what we know here and let's turn it actually into a query that we can work with. To start out, we need to use the keywords create table with the name of the table that we want to create. In this case, it's movies. Next, it's good standard to include the primary key first inside of the query. To create the primary key, we first start out with movie ID, the name of our column, then the data type, which is integer, and then the keyword primary, and then key, to tell our table that this will be the primary key in the table. Then it's followed by auto increment. Auto increment is a command that will increment our movie ID by 1 every time a new entry is entered into our table, therefore keeping our movie ID unique. Next, we'll start at the top entering in title with varchar following with 120 characters with at the very end a comma. After that, years released with integer as its data type with a comma, then finally director as a varchar with 80 to complete our query. Now let's move back to SQL Workbench and try this out. So let's come back, open up a new query tab here, and paste that query we just created. Make sure that movie buff is selected under schemas. Next, we'll run it, and at the very bottom we see that it was created. However, we don't see the table on the left side for schemas. So this is the case for you as well. Make sure that you right-click on movie buffs and press refresh all. After that, the table will show up. And there we go, we've created our first table. So let's move on now to the directors table. Again, here we're going to take a step back. We're going to design first and then implement second. Here we've already drawn out our directors table with first name, for example, Ruben, last name, for example, Fleischer, country being United States, and director ID being 1. So let's go through each and assign it a data type. Ruben is a name, a first name, and therefore it should be a string, or again, a varchar of length 40. Fleischer is a last name, which will also be a varchar of length 40. Then third, United States, a varchar of 80. These numbers are really just best guesses. We're seeing 40 as no first name should be longer than 40 characters. Same with last name. No last name should be more than 40 characters, though some might exist. Then finally, our director ID should be an integer. The last thing we need to do is take a look at this table and ask ourselves which column should be the primary key. We see director ID as being that unique identifier, therefore director ID should be the primary key. So let's go back into MySQL Workbench and create this query. So now that we're back, I've pasted the directors query into a new query window. On the first line, we see director ID, again as that primary key using the keywords primary and key with auto increment. Then we have our first name, our last name, and our country. So let's go ahead and make sure that movie buff again is selected, then run this. So great, we see the query is executed, but we don't see our directors table in the tables on the left side. Therefore, let's right click on tables, refresh all, and now we see it. Great, we have our movies table and our directors table created. So now let's look at both of these tables and see if we can possibly relate them in any way using some of their columns. So here are both of our tables. Let's take a really close look and see if there's anything within the movies table or the directors table that could possibly be linked. In directors, does the director's first name, last name, country, or director's ID have any information regarding a movie? No. So let's take a look at the movies table. The title, the year released, those don't have anything to do with directors. But then we come down to the director's name. But we know a director is more than their first name and last name. They also have their country of origin. All this information could be stored in the movies table, but we already have that information stored in the directors table. So instead of duplicating this information, let's combine it or relate it. And how could we do that? What can we use in the directors table to relate it in the movies table? The director's first name, last name, and country probably wouldn't be the best, mainly because these are not unique. You can have directors with the same first name, last name, and country of origin, but we can't have the same director ID. Again, that's our unique identifier for a table. So therefore, let's use the director ID in our movies table to tell which specific director we're talking about with this certain movie. In order to do this, we're going to have to update director to director ID and varchar to integer. So when we want to update a table, we need to do this in 2 steps. First, we need to drop our table, which essentially means remove it or delete it from our database. Then second, we need to recreate our movies table with that director ID in one of our columns instead of just the director's name. So let's move back to MySQL Workbench and do this now. In a query tab, we're going to use the keyword drop, then table, and then the name of the table that we want to drop, which is movies. We're going to make sure that movie buff is selected and run it. On the left side under schemas, we see that the movies table was removed. So there we go, step 1 finished. Now let's go ahead and build our query to recreate the table. So let's go ahead and paste in the query that's given to us in the studio, and let's go through it real quick. We see that we want to create the table movies, The next line is the movie ID, again that primary key which is an integer that auto increments. Next is the title, which is going to be a varchar of 120 again. The year released is going to be an integer. And then we have our director ID, our new column, which is an integer. And then we have this final line called a foreign key, which is using the director ID that we created on line 5. And it references directors, which we know is a table name. And inside that directors table, we reference the director ID, which we also know to be the primary key. So this foreign key, what it's doing is that it's referencing a primary key in another table. What it does is it creates a relationship between the two tables, allowing our database to know that director ID in our movies table is directly influenced by the director ID in the directors table and all the information in that directors table. For an analogy, think of a foreign ambassador that is a representative from another country. The foreign key is essentially a representative from another table, a foreign table. Hence we call it a foreign key. So now that we have this query created, let's go ahead and run it. First, let's make sure that tables this time is selected. Press our execute button, and then we see that it's been successfully created. In order to actually see it reflected in our tables area under schema, don't forget to right click on tables and then press refresh all. And there we go, we've created our new movies table that has our relationship between it and the directors table. Now let's actually start putting some data into these tables. In order to add information to our database tables, we are going to go to the provided link for the repository, the movie-buff.data.sql file. We're going to click download zip. Once that's downloaded, we're going to open it up. Once we double click on it, we see that it's been imported into our MySQL workbench. So what do these inserts mean? Inserts mean to add into our directors table under the first name, last name, and country column these values. We don't include director ID because we set that to auto increment, meaning that an ID or a director ID will automatically be added into it on insert. The same with movies. Movies, we're going to add the title, the year released, and the director ID. We do not need to add the movie ID in here because again, it will be auto assigned. We'll make sure that under schemas, we still have MovieBuff selected, and then we'll run it. Once we run it, all of these inserts will execute. Before we continue, let's confirm that all of this data has been entered into our tables. We'll go to tables underneath schemas, go into our directors, and we see an icon here that looks like a grid. Let's click on that. This will show us almost like an Excel version of our table. We see that the information that we saw in the .sql file that we downloaded has been inserted into our directors table. Great. Let's move on to movies. Click that same icon. We see that information has also been inserted here. Now let's go ahead and do something with this data. So in the studio, we have a list of tasks to complete. The first task on our list is to list just the titles of all the movies in our database. With that, we use the select keyword, the column we want to select from, which is title, and then we say which database we want to select from. In this case, it's from, which is also a keyword, movies, which is the database. Let's try this out in MySQL database and see what we get. So we paste in select title from movies, we make sure MovieBuff is selected, and then we run it. Here we get all of the titles back for our movies that are in our database. The next task we have is to list the title and the year of each movie in the database in descending order of the year it was released. In this one, we're going to be using that select keyword again. It said to select the title and the year released from movies, which is the database table we need to look at. It said we needed to order these in descending order. To do this, we use the order by keyword, and then we tell it which column that we want to order by in an ascending or descending order. So let's try out this query. So we paste in our query, we run it, and we get back in a descending order all of our movie titles. Great, so now that we're showing two columns and we know how to order things, let's move on. Our third task is to list all of the columns for all records of the directors table in ascending alphabetical order based on the director's country of origin. So we're going to be using a lot of things that we just learned from the past two tasks. We're going to use that select keyword, but in this case, we don't want to select a specific column, we want everything. Therefore, we use the asterisk to tell our query that we want everything back, all of the records, from directors, our database table, and then order by country in ascending order, aka alphabetically. So let's check this one out. We paste this into our query, We run it, and we see we get back all the records for all of our directors with the country being alphabetized. Great, let's move on. Our fourth task is to list all columns for all records of the directors table in ascending alphabetical order, first by the director's country of origin, and then by the director's last name. To do this, we're going to use select, use the asterisk again because we want all of the records back from our directors table, and we're going to order by country in ascending order, comma, last name, ascending order as well. We run it and we see we're getting back all the same directors. We see that we have all of our countries alphabetized on the left-hand side, and then beneath that, we have our last names that are also alphabetized within the country. Great, let's move on to our fifth item. Now we need to insert a new row into the directors table for Rob Reiner, an American film director. For this, we use insert into, and then the table name that we want to insert into, which is directors. After that, we need to tell the query exactly which columns we're going to insert information. In this case, it's first name, the column last name, and the column country, with the values Rob, the first name, Reiner, the last name, and USA, which is the country of origin. So let's try this out now. Here's our query, but before we execute it, take very close attention to the colors of the strings in our values. The strings typically change to different colors, so make sure before you execute your query that the colors are different. If not, it could be indicating that there might be something wrong with one of your values. So let's go ahead and execute this, and let's go to our directors table. We see that Rob Reiner has been inserted. Great, let's move on. Next, we have to get the last name and the director ID for Rob Reiner out of our database. In order to do that, we're going to be using the select keyword that we have been, but we're going to be introducing something new. We have the select keyword from directors, our database table, but now we're using the keyword where. This tells us which condition needs to be met in order to retrieve that data. In this case, the first name needs to equal Rob. So let's try this out. We have our query here. We're going to run it. And we're going to see that we get back the last name Reiner, and the director ID is 11. Awesome. In addition, if we want to get more granular, we can also add more to these where conditions by using the keyword and or. In this case, we might be looking for something with Rob as the first name, but if another Rob is from another country, we might get back more than one result. Therefore, we can make it more specific by adding this and country equaling USA. You did not have to include this to get back the proper results. This is just showing you something to help you out, maybe to make your searches in the future a little bit more specific. Now we want to insert a new record into the movies table for The Princess Bride, which was released in 1987 and directed by Rob Reiner. We're going to use insert into as our keywords into the database table movies under the columns title, year released, and director ID, and then defining those values with the values keyword Princess Bride 1987 and 11, which is the director ID of Rob Reiner. So we're going to execute this, look into our movies table, and see that the Princess Bride is now in there. Fantastic. So far we've just been using director ID as a number, but that doesn't really give us any information. We don't have any of the directors' first names or last name or country of origin, so let's use the inner join that we learned in our reading to get that information back from the database using the director ID and use the relationship we've built between the movies and the directors table. To do this, we're going to use the select. We're going to get back the title, year released, and last name from movies. But as we know, last name is in the directors table, not the movies table. So to get back the last name information, we need to make sure that we join directors into our movies table by using the keyword and or join. We then use the keyword on to define our conditional. And our conditional is when the movie's director ID equals the director's ID, then we need to join that information into our movies row. So let's take a look at the results. We pasted our query in here. We'll execute it. And we see now that we're getting back a list of our movies with the year release of that movie and the last name of its director, because we're pulling in that last name information from the directors table and populating it here, making that relationship between the two tables a lot more useful. Now we need to list all the movies in the database along with the first and last name of the director, and then order this list alphabetically by the director's last name. We're going to use select. We're going to select the title, the first name of the director, and the last name of the director, which means we're going to have to pull information from the movies and the directors table. We're going to pull in from movies. We're going to do that inner join again on the directors on when the movie's director ID equals the director's director ID. And finally, we were asked to order our results by the last name of the director in alphabetical order. Let's take a look at the results. Once we run this query, we see we get back all of the movies with the first and last name of the director, with the last name being alphabetized. On our 10th task, we were asked to list the first and last name for the directors of The Incredibles. It says we can do this either using the join or a where command, but it's really recommending to use the where command. So that's what we're going to do here. In this one, we're going to select the first name and last name of the director, use the table from movies, do an inner join on directors, And then we say where the title equals Incredibles. So what this is saying is that we want to return only the movie that has the title Incredibles. So let's take a look at this result. Once we plug in our query, we're going to run it. So we see our director come back with the first name Brad and the last name Bird. In this task, we need to list the last name and the country of origin for the director of Roma. We can do this either using a join or a where command, but for this one, we're going to use join. To do this, we're going to select the last name and the country of origin from movies, but we know that this is not movie information. So therefore, we need to do the inner join on directors again, and then we use the and command and say title equals Roma. This means that in that inner join, the information will not be combined unless the director IDs are equal and the movie title is equal to Roma. So let's take a look at this. We paste in our query, we run it, and we see our last name and then our country of origin are directly returned. Great, let's continue. On task number 12, they want us to delete a row from the movies table and observe any consequence it has on directors. In order to delete an entry out of a table, we need to use the keyword delete, then from the table in which we want to do it at, which is movies, and a conditional, where some kind of conditional, in this case, movie ID equals 1. I pasted my query here, and our example originally had 1, but here I'm going to put 17, which is going to be Princess Bride in our movies table, and we're going to execute this. We're going to relist out movies, and we see that the entry is gone. Let's go and list out our directors table, and we see that nothing has changed in our directors table. Before we continue, I'm going to reinsert Princess Bride back into our movies table. Finally, on task 13, we need to try to delete one person from the directors table, and then review the error results trying to remove a director. To do this, we're going to use the keyword again, delete, from directors, where director ID equals some number. I'm going to paste in my query, and instead of 1 like we have in our example, I'm going to use Rob Reiner, which is 11, that we know is attached to Princess Bride. So let's go ahead and run this. We see that we get an error down in our console. Cannot delete or update a parent row. A foreign key constraint fails. What this is saying is that it cannot delete this entry of directors because it is directly linked to another entry in our movies table. That relationship still exists. Therefore, deleting this director would intentionally violate that relationship. And that's a wrap for the main portion of the studio. If you got to this point, great job. If you want to stick around for the bonus missions, that'll be next. Let's dive into the bonus missions. On this one, we have 3 specific bonus missions that we could have completed. The first one is asking us about aliases. To give our column a temporary name. This could be because a column name is too complicated for someone to read, or it just doesn't look nice, and you want to format it so people can read it better. In order to do this, we use select first name, and then we use our new keyword called as. And then what we want to name that column, in this case, I'm using first name from our directors table as an example. And of course I say from directors or the directors table. Let's see what this looks like. We paste in our query, we run it, and now we get back exactly what we expect, but now our column name says first name in a well-formatted way. Our next task was to list all of the movies in the database that were directed by Peter Jackson. There are many ways we could do this. The one I chose is using select, the title of the movie, from movies, the table, and then we need to do that inner join to get that director ID of Peter Jackson, where first name equals Peter and last name equals Jackson. Let's see what the results are. I paste this query, I run it, and I see that Peter Jackson has directed The Lord of the Rings, Return of the King. The final bonus mission that we have has 4 parts. The first one states, add another column to the movies table that holds the amount of money earned by each film. In order to do so, we use a new keyword called alter, then the word table, the table that we want to alter, which is movies, and then the keyword add, followed by the new column name, which in this case I'm calling amount money earned, and then the data type. Money has a decimal in it, so I wanted to select double because we might have change that would be associated with our money amount. We paste in our query, we run it, and now we're going to look at our movies table. We see that amount money earned, the column, has now been inserted, but only has null values. That's because we haven't added any value into these columns. That leads us to our next part. On 3B, it says use update to enter these values for each movie in the database, meaning that we need to provide a value for amount money earned for each row in our movies table. To do this, we use the update keyword, the table that we want to update, which is movies, the keyword set, then the column name that we want to set or update, which is amount money earned, and then equal to whatever value you want it to be. In this case, I just picked a random number. And then you need to tell it where it needs to set this information, which row it needs to set. In that case, we use a conditional. It says where movie ID equals 1. So let's go ahead and run this. We paste it in our query, we run it, and now let's take a look at our movies. We see that under movie ID 1, our amount earned has been updated. Great. So now we need to update 2 through 18. So in order to do that, I've created a file to help us out. That starts at movie ID 2, and it goes down to 18. We run this, take a look at our movies, and we have updated all of our values. Great, that's exactly what we want to see. Part 3C says we need to generate a list that ranks the movie's titles based on earnings. In order to do that, we use everything that we've already learned before. The select keyword under title to get that title back from movies, and then we use that order by keyword to order it by the amount money earned in descending order. Running this, we see that we have the greatest amount money earned first, which is A Bug's Life, and it goes down to Crouching Tiger, Hidden Dragon, which is the least amount of random numbers we generated while building this list. Our final task is, on 3D, to generate a list that only shows films that have earned above or below a certain amount. In this one, I'm going to print out everything that has the earnings above $1 million. This is how we will do it. Using that select keyword again, the from keyword that we're very familiar with, but then under the where conditional, we have something that we haven't seen yet in the studio. We use the column amount money earned, but we know amount money earned is a numeric value. So we use the greater than symbol and then 1 million. Running this, and we see we get back results with only the movies that have over a $1 million grossing. Great job, everyone. This is the end of that studio. I hope this has helped you answer some questions and further your knowledge about SQL.